Hello everyone, welcome to Unit 1 Guiding Notes for 1-2 Density. In this we will look at the guiding question, what does density of a substance measure, including at the particle level? The do now is below. You will complete the problem and record it to the correct sig figs for your answer. So notes, density is an intensive property. Remember that intensive properties are physical properties that do not change if we change the amount of the substance we're studying. So if we have, say, gold and we increased its mass or decreased its mass, the density of gold is always going to be the same regardless of how much we have. So an intensive property does not change regardless of how much we have of it. It's going to stay the same. Density is useful to identify substances because no matter how much of the material you have, density is going to remain constant. So density is a measure of how much mass is in a certain amount of space. So how closely packed particles are in a model. So if we looked at two models of density and we had this one where we had particles in there, and then we have the same size box, pretend it's the same size, and we had a lot more in there, particles, we would say that the density is much greater in the one on the right than the one on the left because they're more closely packed to each other. There are more particles, and I could even make them about the same size, in these other ones. So the density, because they are more closely packed together, or there's more mass in a specific amount of space, this one has a higher density on the right. So density is calculated by dividing the mass by the volume. So it's a ratio between two extensive physical properties of a substance. To find the mass of an object, you weigh it on a balance or a scale. So we have a digital scale here, or balance. To find the volume, you can do it in different ways based on the material. Liquids can be found using a graduated cylinder. You can also do volume displacement, which is this one here, using water displacement. So the volume of the object that is in here is the volume of the water and the object, which is up there, minus the volume of just the water that was originally. You can also use geometric equations here to determine the volume of an object as well. Please note that 1 milliliter is equal to 1 cubic centimeter, so those are interchangeable. Okay, so we're going to practice a little bit here. So you wanted to measure the volume of an irregularly shaped rock using water displacement to find the volume. You started by measuring the mass of the rock before you put it in the water. The mass was 10 grams. You put 3.9 milliliters of water in the graduated cylinder and then added the rock. The volume of the water and the rock together was 25.7 milliliters, and we want to calculate the density of the rock. So density is equal to mass over volume. It tells us that we measured the mass to be 10.7 grams. Volume, we don't know exactly, but we know from this slide that it's the water in the object minus the volume of water. So water in object was the bigger one, which is 25.7 milliliters minus 23.9 milliliters. So then now we would do our math, and 25.7 minus 23.9 is 1.8 milliliters. Tenths place is recorded for both volume measurements, so that is an acceptable significant figure there. So then calculating density, we would substitute in for mass and volume. So 10.7 grams over 1.8 milliliters. Plugging this into our calculator, 10.7 divided by 1.8 is 5.944, repeating, grams per milliliter. Looking back at sig figs, this, since it's division, we look at total, so 3 and 2. We're going to keep 2 sig figs, so 9, and the 4 says to round down and keep it at 9. So we would go 5.9 grams per milliliter would be our final answer. Continuing on, you are going to scan the QR code for the we do's and complete those along with the videos. Then you will complete the you do's on your own. When you are finished, answer the guiding question at the end of your notes. If you are absent, you may upload your notes to Schoology and submit them to the assignment there, or you can turn them in when you return to class. Thank you, everyone.